everyone, welcome to our YouTube channel. So today we will discuss about our model diabetic prediction. So our workflow is that we will input our data into our collab or our IDE or any code editor. Then we will process it, then analyze our data. Then with the help of standardization, we will standardize our data so that it should be in a sequence of synchronized data to be given to our model, such that we will give our data then after standardization to our SVM model that is sport vector machine that will help in linearly separating our data into 0 and 1. Then we will predict our data, evaluate our data on our 10 sample valuation. So let's discuss our model. So let's start it. So first we will install our libraries. So first we input pandas as pd and numpy as np. We will import different libraries according to the cells, so we will understand our data, our steps clearly, how our libraries are using in their respective function or in their respective cells. So we use this our file link, and we use pandas.pd_csv function to read our file. We will make new variable data is equals to, we will give use our function pandas_pd.read_csv, and we will give it our path. So we will run our data, our cell. Now we will use another step of data analysis. We use our dataset variable .describe. This function help us to identify, understand different features and their respective count, mean, median, mode, statistical approachable functions. Okay, this is statistic basically. So we use an other analysis step, which is basically data dot add. These will give us first 5 rows of our data in tabular form. Our data is basically tabular form, data is in tabular form, so we will use head of first 5 rows, and then tail, it will basically opposite of head, will display last 5 rows. So now check our last 5 rows. So we will use a function isNull.sum. It will calculate, it will identify is there any missing values in our data. So it will collect all these null values and sum it and give it in a collective form that according to the features. Means look now, as we have no missing values, if there is any missing values in any rows of particular feature names, it will give us, as there is for example 10 missing values in glucose, 20 missing values in PMI, for example. Okay, as there is no missing values, so it is displaying no missing values. Our main outcome basically is 0, 1. It will help us to find either is diabetic or non-diabetic. So non-diabetic is 0, diabetic is 1. So we will now check value counts for outcome. Means outcome has how many values, means ki how many zeros and how many is 1. Okay, data, we will give our function, our column name data.outcome. Data outcome dot value counts is a function that will calculate the values, 0 values how many and how many 1 are in our data of particular outcome column. Okay, there are 500 0 and 268 1. Okay, now we will add a new cell. Now let's check data dot group by. We will basically find a mean value. Okay, means our outcome function mean value collectively particular mean value of different aspects of feature names. Okay, dot mean. Now check. Look, our zeros mean value and 1 mean value according to their feature names. Okay. Let's see. Outcome 0 mean values according correspondingly to their other features. Okay. So now we will check. That so we will check, draw outcome is our basic function, so we will drop it from our rest of the data so we can use it as our target column. So we will basically passing all our data except outcome to our x variable and dropping our data from outcome from our x variable to our new data set to our new variable y. So basically we are separating our target or rest of our data. So y is equals to data outcome. Run this cell. So we will include new cell, print x and y values. Look how this data is displaying. Now see, our outcome data is missing in x because we have been dropped it. So we will check our y data if there is need any. Now check, our data is so clustered, means our data is very in different values. It is not in synchronized data, not close to each other. So we will standardize this data. Okay, means make it a sequence, make it easy to understand for our our machine. As our data is so much diverse, so much outliers in our data, and it should be very difficult for our machine to understand. So we will use scalar.preprocessing input a standard scalar function. So we make our new variable scalar. Standard scalar function should be considered use, which will help us to make our data standardized. That should be easily to understand for our machine. So we will give our function standard bracket. This is basically function. So we will fit our x data. X data means rest of data that we have been dropped our data from x, from means rest of data that is passed into x. We use x data and should be fit. Okay, scalar.fit is a function. So we will use scalar.fit scale data. Okay, scale data is another variable that will transform these scalar data, these x. Okay, scalar dot transform x. Transform means obviously our data is in different standard, different outliers. It is not standard. It will transform our data into standardized variable. Okay, now we will print our scale data, that transform data from unsorted data to a kind of sorted data. So we'll check what is scalar. Okay, what is in error in our let me check. Scale data, standard scalar. Okay, what is the transform? We have been, our transform spelling is not good, so we will yes. Now check, our data has been transformed into kind of a synchronized data, in kind of listed data. So we use another cell. So now our data has been transformed. Now we use our x variable and we will pass our transform data as we use. We have transferred the x variable data, that the data that has been rest of the target data, outcome data. So we transfer that data and we will make a scale data, and then y means our rest of outcome data, as we have separate our data scale data and y average separate data. So we will run this data cell. Now we will train, test, train, split our model. Means basically we will split our x and y data into x train, y train, x test, y test, into test splitting data, train splitting data via function. Means train, test, split. Okay, we will use from sklearn dot linear model selection. We will import our train, test, split function to separate our data into test and training data. So we basically from sklearn dot model underscore selection import our train, test, split function, import train, test, split function. We will x and y, we will just make a bunch of these. We will separate this, but consider that we are now mixing this, and we will make mixing the data that is outcome that is separate. So we will split this data into x train, x test, y train, y test. You know, understanding. We will make x test, y x test, x train, y test. Then we will give our function that has been imported through model selection, train, test, split. We will give our now function. We will give our function x and y train. And test size is 20%, 0.2%. Our 80 desktop and 80% of our data will be used in training of data. So we will basically use 20%. And it is very important to know the understanding test and training data. And our testing data should be in proportion of 9 or 1, 8 or 2. So random state is any, you can choose any. So basically we will run our data. So we print our shapes, x train, y train की shape, x test, y test shape. X train, x test shape. It will basically display it will display different shapes. Okay, let's run this cell. Now as we have seen, our x train and x test shapes are different. So this is total rows in our data and 8 columns. And now see, our x train data has 614 rows that and 154 rows in our test data. So basically we have split our x data into x train and y test. Okay, y test or x train is, and now check if our y test has only one column. So default it is 1, as our x y column has our outcome data. Just see, we will choose our model for our data prediction or our 0-1 diabetic predictions, non-diabetic prediction. So we will use SVM sport vector machine. Okay, from sklearn import SVM. SVM basically is sport vector machine that is helpful in separating feature data, because we are separating classifying data into 0-1. So we will use SVM sport vector machine. Okay, so we will use SVM. We will use classify. You can use any kind of variable you want to. You can make it model, classifier, anyone, your name, anything. So we will use here model is equals to svm.svc, svm sport vector machine, svm sport vector machine, svc sport vector classifier. Kernel is linear. Linear is basically a simple function that will separate 0 to n by line. Because at the one side of line there is 0, at the one side of the line there is 1. Okay, so we will separate the svm.svc kernel linear. So model dot fit our training data. Training data is x train and y train. Okay, our 80% of data should be fit in our data, in our model. Okay, x train, our model has been trained. So we will predict our training data, prediction on training data. Then we will give our data sample to predict the test data. So first we train our data, we will predict our data on training data. Okay, how our data is responding to our training data, and we will import accuracy. Okay, and we will see how accuracy it is. So sklearn.matrix import accuracy score, and it will display the accuracy of our model. So from sklearn import accuracy score. Now we use our x train we will predict our model through our training data. So xtrain is equals to model.predict xtrain. Okay, we will make it a training because we are predicting training data to make it train, so it should be easy to understand. Note xtrain training is x and y train both. Okay, so xtrain, we will give xtrain y train. So we will test our model. So now we will give our accuracy score. Okay, accuracy score variable. So we will give it our function accuracy score underscore score. Then we will pass our training data to this function. Okay, and training data is train, means we have given our xtrain to our train x y train to our train. So xtrain, and let's it load. So it's the issue. So takes two positional arguments, but 3 were given. Okay, let me check. Okay, we have given our xtrain both target. Okay, we will separate these xtrain and y train. Now check, as we have 0.77. Now make it easy to understand to our user. We will give it our title, or we will pass our string training score is, and it will basically show some understanding data. Training score is in a string form, in a italic string form. So done this. Now we use our test sample to predict our model on the behalf of our test data. The 20% we use. Okay, so hold it. Now we will check our data. We will basically open our text file, choose any kind of sample you want to. Okay, I have choose this now. Okay, use this in our test sample. So we will make a new cell, input sample. We basically give this test sample. Okay, our test sample is equal to, we will give it our sample. Okay, now we will basically, with the help of np numpy that we have been used and we have been import in the very first cell of the video. Okay, we will use this numpy, which will basically help arrays, which will be basically deals in arrays. Okay, and test array np dot as array. Basically it will make our data into a kind of array that is easy to understand for our data. Okay, for our training model. Test sample that we have been given above, reshape. Basically this will reshape our data, and data is in different form. We basically reshape our data into 0 1, as we are predicting diabetic, non-diabetic. Okay, we will give it a one instance. Is 1 to -1 means 1 or 0. So make it for, just comment it, for one instance means 0 or 1. Okay, 0 or 1. Now after making a comment, okay, model.fit. Okay, use this variable test underscore fit, test underscore fit is equals to, so therefore is equals to scalar dot transform our reshape data. Okay, reshape data that will standardize these data. Okay, now we will print our test fit data into through print. Now we will predict. Okay, predict is equal to model.predict our test fit. Okay, if prediction is 0, that means dot fit our model to predict our test fit data that has been reshaped. Okay, print predict. Now if prediction is 0, it's non-diabetic. If prediction is 1, it's diabetic. So basically if else function, the person is non-diabetic 0. Let me done it, check it. Okay, now as we have 1, our value is 1, so person is diabetic according to this sample. If value is 0, the person should be non-diabetic according to our data. So basically this is how our SVM model work, and it classify in data into 0 1. So that's all from my end. Thanks for watching my video. Thank you.